Hello, everybody. Welcome to Sokora tutorials. And in today's video, I will show you how we can run a chi-square test. Of course, the chi-square test of independence is used to analyze frequency table or so-called the contingency table formed by two categorical variables. The chi-square test evaluates whether there is a significant association between categories of two variables, which are categorical ones. And in addition to that, I will show you how we can read data from the SPSS. I have saved data here in SPSS in my root here as shown. And to read this data, I need to use a foreign package. So to install foreign package, I only make this command here on line number 110 in this case, install package, then I write the name of package here. Then after doing all installation here, I go to calling this actually giving library or required here. Then I need to call this and I run this command. Then after I use in this particular package, there is a function called read SPSS. So using this package and giving all the root where my data is located, and then I add the command to data frame, read as a data frame, then this helps me to read this uh, data into R in this case. So I read my data and I have a lot of variables in my case and of course observations as well. Then I'm particularly interested. This study is particularly conducted on the performance of students, and I would like to see whether there is really dependency or a really significant association between the program that at which the students are enrolled and the sex of the student. So I select these two variables, particularly using dollar sign, giving name of data, then dollar sign, I select a particular variable program, and then sex of student in this case. I used table here to build frequency table. Then I run this command. As I run the other command, I can see frequency of frequency here, like the programs are listed in here and as rows, and as column there are the sex of students, and we can see the frequency of each actually like program, how many male are there in this particular program and how many female. Actually, this does not mean that whole program is involved in a study, the sample of students in each program. Then after doing this, we can show this data actually as a plot also. Like this frequency table can be shown as plots. To do that, I need to load, following the same procedure as I have shown above, this gplot package. And as I do that, I use the particular command here, balloon plots. Actually, it shows us like the points, and the size of points also shows like how the proportion of that particular category, the observed value, how big the observed value, and how small the observed value is. So here I run this command. Of course, I have to maximize this side to show you the graphs here. Uh, so as you can see, of course, the points are very small ones. they are not nicely visible in this case, but we can nicely see that the programs are here as a row, and we can see the frequencies as a table here. So there is also uh, other actually the function in graphics which show more nicer than that one, and this function is so-called mosaic plot, and mosaic plot show nicer than that one. You can see how nicely it is shown here. From this, the blue color indicates that the observed value is higher than the expected value in data, and the red colors shows that observed value is lower than the expected value from actually each data. The size of each bars here indicates the proportion of a data, like the number of frequency, how big it is. So then doing after this all, actually we move to the chi-square. Basically in chi-square, we should test the hypothesis in this case. We examine whether rows and columns which we are looking here are actually statistically significantly associated with one another or not. Therefore, we need to test a null hypothesis and alternative hypothesis. In this case, the rows and column variables of the contingency table are independent, that is null hypothesis, and alternative hypothesis also there, that is the other way round of this particular hypothesis, that is rows and column variables are independent or dependent in this case. In other case, it was independent. So we need to run here chi-square, and after running chi-square to see how big, like the p-value, we have to run this one, and we can see the chi-square value here. And after looking that chi-square value, we also see the basically here the degree of freedom and p-value. And you can imagine how small the p-value is. It is 2.2 e power of minus 16, which is 0.0000, nearly zero actually. So in our example, rows and the column variables are statistically significantly associated, which means in this case. So then we can also see that already we have observed value. We can see observed value. What would be expected value? Actually, this chi-square test give us a lot of option here, like residuals, expected value. Even we can run basically the correlation of the residuals, how they look like this, for example. So basically, like from this, we can conclude that in our particular example, the program categories or the frequencies under the program are statistically significantly associated with the sex of students in this case. So this is how we can nicely test our basically categorical variables using chi-square test. Thank you very much for watching, and you consider subscribing my channel to get more videos as soon I load to the YouTube. Thank you very much.